All right, welcome. Today we are cracking the code on one of the most powerful tools in your entire Precalculus toolkit, the Pythagorean Identities. They're fundamental, they're kind of elegant, and once you get the hang of them, you'll be simplifying these crazy-looking problems like it's nothing. So let's get right into it. So just think about this for a second. That simple rule you learned way back when for right triangles, a squared plus b squared equals c squared, what if it's been hiding in plain sight this whole time, ready to unlock a whole new level of trig for you? Well, that's exactly what we're about to find out. So, first things first, we need to build a little bridge from something you know really, really well to where we're headed. We're going to take that classic theorem and give it a complete trigonometric makeover. I mean, you've seen this 1,000 times, right? The Pythagorean theorem. It's the absolute bedrock of geometry. It connects the sides of a right triangle. We're going to use this exact formula as our launch pad. No complicated new rules to start, just this old friend. And here is the key idea. A Pythagorean identity is really just the Pythagorean theorem, translated. That's it. So instead of side lengths a, b, and c, we're going to use trig functions, like sine and cosine. It's the same core concept, just spoken in a different language. Okay, let's get to the heart of it. Let's see what these identities actually look like. There are three main ones, and trust me, they form the foundation for basically everything we're about to do. This right here, this is the big one. This is the cornerstone. Sine squared theta plus cosine squared theta always equals 1. If you only remember one thing from this whole explainer, please make it this. It comes directly from the unit circle, where the radius, which is just the hypotenuse, is always 1. It's so simple but unbelievably powerful. Now here's the really cool part. The other two identities, they aren't totally new rules you have to memorize from scratch. Nope, they're just different versions of the first one. So you start with our main identity, and then watch this. You divide every single term by cosine squared, and things just start to simplify. Sine over cosine becomes tangent, cosine over itself is just 1, and 1 over cosine, well, that gives us secant. See? It's not magic, it's just algebra. So here they are, all three of them, all together. I want you to think of these as three essential tools in your toolkit. The first one, that's your big multi-purpose wrench. The other two are just derived from it. We got the second one by dividing by cosine squared, and you can probably guess how we get the third one, right? We just divide that original identity by sine squared instead. With these three in your back pocket, you are ready for some serious trig problems. All right, enough theory. You know the best way to really understand these tools is to actually see them work. So let's put these identities into action with a couple of classic examples. Okay, here's a typical problem you might see on a test. Simplify the expression sine squared of x plus cosine squared of x plus tangent squared of x. Yeah, it looks a little messy, a little clunky, but just watch how our new tools clean this thing up in no time. This shows the whole process perfectly. First, you spot our star player right at the beginning, sine squared plus cosine squared. We immediately swap that whole thing out for the number 1. So now our expression is just 1 plus tangent squared of x. And that should ring a bell. That's our second identity, which is equal to secant squared. So that whole long expression just simplifies right down to secant squared of x. So clean. Okay, let's try a different kind of problem. This time, we're not just simplifying something, we are finding a specific value. We're told that the sine of theta is 3/5, and we know the angle is somewhere in quadrant I. The mission? Find the cosine of theta. So, we start with our main identity, and we just plug in what we know, which is that sine is 3/5. A little bit of arithmetic, and we get down to cosine squared equals 16 over 25. Now stop. This is the crucial point. When we take that square root, the answer could be positive or negative. But the problem gives us a clue. It tells us we're in quadrant I, and in quadrant I, cosine is always positive. So our answer has to be the positive 4/5. Look, using these identities is a skill. And like any skill, there are some common mistakes people make when they're starting out. So let's just highlight a couple of them right now so you can sidestep them completely. This is the number 1 trap. We just saw it in that last example. When you solve for a trig function and you have to take a square root, you have to pause and ask yourself, which quadrant am I in? That one question tells you if you need the positive or the negative root. Don't let this simple little step trip you up. Here's another common slip-up, just mixing up the second and third identities. It's really easy to do. A great way to remember it is that the number 1 is always paired up with tangent squared or cotangent squared. It's always 1 plus tangent squared or 1 plus cotangent squared. Keep that little rule in mind and you'll keep them straight. So, okay, we can simplify expressions, we can find values, but what's the big picture here? Why is it so important to master this stuff? Let's just zoom out for a second and see the real-world impact. Yeah, this isn't just abstract math for a test. In electrical engineering, these exact identities are used all the time to analyze alternating current circuits. That relationship between sine and cosine is fundamental to something called the power factor in our electrical grid. This math literally helps power our world. And looking ahead, if you're on the math track, this is an absolutely essential key for calculus. You will hit problems, especially with integration, that look impossible until you use one of these identities to simplify them first. Mastering this now is a direct investment in your future success. Seriously. And, that's really what it all comes down to. These identities are just these elegant tools for transformation. They take something that looks really complicated and they reveal the simple core relationship hiding underneath. They're a mathematical cheat code for clarity. So the only question left is, what will you use them to simplify next?